All right, everybody. Your first lesson for Middle School Pre-Algebra 1 is going to be all about factors. So let's take a look at our focus for today's lesson. Our focus is going to be to identify prime and composite numbers and to find the greatest common factor. Our essential question of the day is, how do you find the greatest common factor, also known as the GCF of two numbers? Now we're going to refer back to this question at the end of the lesson to see if you are able to answer it successfully. If not, I would encourage you to go back through this lesson, review the terms and the examples that we're going to go over to see if you can answer this question. To start, let's establish some vocabulary terms. The first vocabulary term that we're going to talk about is divisible. When a number is divisible, it is when it is divisible by a second number and have a remainder of 0. So, for example, numbers that are divisible by 2, the ones digit or the last digit of a number will end in 0, 2, 4, 6, or 8. They are all even numbers. To be divisible by 3, the sum of all digits will be divisible by 3. In other words, we're going to be able to divide that number by 3 to figure out if it's divisible by 3. That is what divisible means. We're going to be working with division. So, an example of a number that is divisible by 4, it says when the last two digits are divisible by 4. Divisible by 5, when the ones digit is a 0 or a 5. So an example of that would be the number 25. That is divisible by 5 because when we divide it by 5, we're going to equal 5 as well. We have a remainder of 0. We don't have any decimals. And the same thing goes on with the divisibility rules. And you can use this chart at any time to help you figure out when numbers are divisible and what they're divisible by. This will come in very handy when we are working with prime factorization. But in order to know what prime factorization is and to solve for it, we need to have a strong understanding of what a prime number is. A prime number is a whole number greater than 1 with exactly two factors, 1 and itself. So in other words, a prime number can only be divided by itself and 1. An example is the number 43. 43 is a prime number because it's divisible only by 1 and itself, 43. So in opposite terms, when a number isn't prime, it is then composite. It's a whole number greater than 1 with more than two factors. For example, the number 54 is a composite number because it is divisible by 2. We're able to tell that it is divisible by 2 by the last value. It's an even number, so we can divide it by 2. As stated earlier in the lesson, we talked a little bit about prime factorization. Prime factorization is a composite number written as a product of prime numbers. So, in this example, you will see we're going to use a factor tree to find the prime factorization of the number 54. The number 54 is divisible by 2 because it is an even number, as we established in our last slide. Because the value 4 is an even number, we're going to divide that by 2. When we divide 54 by 2, we get the value of 27. We're going to continue that factor tree by dividing 27 by another prime number. Another prime number that's divisible by 27 is 3. When we divide 27 by 3, that equals 9. And then the two values that are divisible by 9 are 3 and 3. And we're going to stop our factor tree when all of our factors are prime. And one way you can do that is by circling all the prime numbers so that you know that they aren't divisible by anything else. So the prime factorization of 54 would be 2 times 3 times 3 times 3. Another way to write that would be 2 times 3 cubed. or 2 times 3 to the third power. This next vocabulary term goes directly in correlation with your essential question, the GCF. The GCF is the greatest common factor of 2 or more numbers that is the greatest number that is a factor of all numbers. Well, geez, that definition just sounds really fancy. So let's think of another way to define what a GCF is. Maybe another way that you can think about it might be that a GCF, the greatest common factor, is the biggest number that is in common with both of the values that are given. So let's take a look at this example where we're asked to find the GCF of 2 values, 42 and 36. We begin finding all of the factors of these numbers. So factors are the numbers that go into 42. In this case, 1 divided by 42 is 42. 2 times 21 is 42. 3 times 14 equals 42. And 6 times 7 equals 42. We've gone from 1 to 42, so those are all of the factors of that value. Same with 36. Now we're left to identify, once we have listed out all of the factors of both of the values, we're left to figure out what number is the largest, what's the greatest number in common with both of these values. In this example, you can see that the value 6 is the biggest number that both of these values have in common. The GCF, the greatest common factor of 42 and 36, is 6 in this example. So let's get started with some examples that you can do on your own to practice prime factorization, identifying whether numbers are prime or composite, and solving for the greatest common factor of different values. The first example that we're going to take a look at is we're asked to identify if 15,482 is a prime or a composite number. We also have to explain our rationale as to why it is a prime or composite number. So let's take a look at that value itself. We have 15,482. Right off the bat, I'm thinking of my divisibility rules, and I know that the last value of this number is an even number. So I already know that it's going to be divisible by 2, which means that it is a composite number. Because if it were a prime number, it would only be divisible by 1 in itself. Moving on, we're asked to use a factor tree in order to find the prime factorization of the value 96. So let's start by writing our value 96. I know that this number is an even number, so I'm going to start by dividing my original value of 96 by 2, which is a prime number. So I'm going to circle it because I know that that limb of our factor tree is prime. When we divide 96 by 2, it equals 48. So that is our other branch of our factor tree. But 48 is an even number, so I'm going to divide that in half again. 48 divided by 2 is equal to 24. So there's my other branch. We're just going to keep on going till all we're left with are prime numbers. 24 is an even number as well, so I'm going to divide that by 2. 24 divided by 2, so we're going to divide that in half, is equal to 12. 12 again is an even number, so we are going to divide that in half. 12 divided by 2 is equal to 6. Now, 6 is an even number again, so I'm going to divide that in half, which is 2. 6 divided in half equals 3. And 3 is a prime number as well. So the prime factorization of the value 96 is equal to 2 to the 5th power times 3. because if we look, we have 1, 2, 3, 4, 5 values of 2, which is a prime number, and 3. So we factor our base of 2 with an exponent of 5. Now let's take a look at finding the greatest common factor of two values. In this case, we have the value of 54 and the value of 63. The first thing that we're going to do is to list out the factors of both of these values. I know that 54 divided by itself is going to be 1. 1 times 54 equals 54. 54 is an even number, so I'm going to divide it in half. 54 divided by 2 is 27. 54 is also divisible by 3. When we divide 54 divided by 3, we get 18, so that's another factor. And 54 is also divisible by 6. 54 divided by 6 equals 9. And those are all of the factors of 54. Now let's take a look at all the factors of 63. 63 is a little trickier. Obviously, 1 and 63 are factors of that. Also, when we divide 63 by 3, that equals 21. Next, we have 63 is divisible by 7. When we divide 63 by 7, that equals 9. And these are all of the factors of 63. Now we have to just take a look and figure out which factor of both of these numbers is the largest and in common with both of them. Well, they have one in common. Okay, so let's see if there's a bigger value. We have 3 and 3. See if there's any more. 6, well, we don't have any of those. 9 and 9. Whoops. All right, so it looks like 9 is the factor that's the largest that's in common with both of these values. So in this case, 54 and 63, their GCF, their greatest common factor, is equal to 9. Now we're at the point of the lesson where we're going to review what we have done. We've talked about what makes a number prime, what makes a number composite. We've talked about the greatest common factor, and we've talked about prime factorization using factor trees. So let me ask you this question now. How do you find the greatest common factor of two numbers? What is your thought process when it comes to finding that greatest common factor? I'll give you a few moments to think about that. Alrighty, let's go back to this question. How do you find the greatest common factor of two numbers? Well, one would say that you would list out all of the factors of those particular numbers and figure out which number is the biggest and in common with both of those values. If you have any questions regarding this lesson about factors, please don't hesitate to contact me. But I would encourage you to right now complete all the questions below in this lesson, and then you can move on to the next lesson. Good luck!